we have talked about the derivatives of just inverse functions in general, and now we're going to talk about the derivatives of the inverse trig functions. So that's what this lesson will be about, and this will be kind of this will complete your formulas that you need. All right, so we're basically going to use some ratios of right triangles to basically show why these formulas are what they are, and then we'll talk about ways to learn them and which ones we use the most and things like that. Okay, so in this first example, we're going to say that we've got y equals sine inverse of x. Make sure you don't think that means sine of x to the -1. That's not what it means. Very important to remember that. It means sine inverse of x, and you shouldn't even say sine -1. You should say sine inverse of x. We want to find the derivative. Well, to find the derivative, we need to remember what y equals sine inverse of x means. It means that sine y equals x. That's the definition of the inverse trig functions, and this is stuff that we did in course in pre-calculus. So we want to take the derivative of both sides. This is why we needed implicit differentiation first, because we're going to need to do this derivative without it solved for y, because we don't know that formula yet. And so we're going to do the derivative and then get our solution in terms of x. So the derivative of sine of y would be cosine of y, but then y isn't x, so that's times dy dx, because we have to use the chain rule. And then the derivative with respect to x of x is 1. So that means that dy dx equals 1 over cosine of y. Well, we're going to use this triangle over here to help us remember and figure out a way to get this in terms of x. So cosine of y, so we're talking about this angle right here. So we know from the fact that we have y equals sine inverse of x means that sine of y equals x over 1, and sine is opposite over hypotenuse. Okay, so sine of y equals x over 1. But what I'm wanting is to get rid of this cosine of y. So to get rid of cosine of y, I need adjacent over hypotenuse. So I have to use the Pythagorean theorem to get this expression for adjacent. If you need practice on Pythagorean theorem, this would be a great time to do it. Little things like that come up all the time, so it's important to know that. And so adjacent over hypotenuse means that, in fact, cosine of y equals the square root of 1 minus x squared over 1. So, of course, just the square root of 1 minus x squared. So that means that my actual formula for the derivative of y, okay, derivative of y, so the derivative of this is, in fact, 1 over the square root of 1 minus x squared. So that's kind of the proof of that one. So we're going to go ahead and do cosine and tangent, and then that's it. And those are normally the three that we see ever with inverses. We don't really see the other ones very often, but we're going to learn them because it's just always good to know formulas and know they exist. So we're going to do the same thing here. This time we know that y equals cosine inverse of x is the same thing as saying cosine y equals x. So if this is the y in our situation, cosine is adjacent over hypotenuse. So again, using Pythagorean theorem, that will be the value of opposite. So I'm going to do the same thing that I did, derivative of both sides. So I'm taking the derivative of cosine of y and then the derivative of x. Derivative of cosine is the opposite of sine. So you'll have the opposite of sine y, and then of course it's not x, so we have to take it times dy dx. Derivative of x is 1. So solving, we get dy dx equals negative 1 over sine y. You could put the negative in the bottom, but it's kind of common to put it in the top. One negative is one negative, top, middle, bottom, doesn't really matter, but we'll move it to the top. And then looking at our graph, if this is y here on the bottom, sine would be opposite over hypotenuse. So this ends up being negative 1 over the square root of 1 minus x squared. So notice how similar the formula is. It just happens to be negative. Well, that's a wonderful, fantastic thing that happens, and so we'll see that in just a second. So now let's do tangent. Same idea. Y equals tangent inverse of x is the same thing as saying tangent y equals x. That's what inverse means. So tangent of y, so now we have y still over here in our corner. Tangent is opposite over adjacent, so there's our values. Again, Pythagorean theorem to find this side. So we're going to do the same thing. We're going to do the derivative of tangent y and derivative of x, because we do always both sides, always do the same thing to both sides. Derivative of tangent y, secant squared y, but again, it's not x, so times dy dx equals 1. So dy dx equals 1 over secant squared of y. Well, secant squared of y would be the same thing as 1 over cosine squared of y, because that's how they relate. And then cosine is again adjacent over hypotenuse. So you're going to get adjacent is, or well, actually, we could even make it quicker. We can just do, well, we'll just go ahead and do that. So it's 1 over cosine squared. So I'm going to write down what just secant, this is 1 over cosine squared. So it's going to be 1 over square root squared. So that'll be that. And then, of course, this whole thing is in the denominator. So it ends up putting it back to being 1 over 1 plus x squared. Okay? So that's dy dx. Now, you're not responsible for knowing how these are developed. It just sometimes helps to make sense why they look like that. Okay? So here are our formulas. So the thing that is important, or here's the reminders of the definitions of your inverse functions. So be sure you look at that carefully. Okay, so it's most important to know inverse formulas for sine, cosine, and tangent. Okay, it's really not the rest of them that often, but if you'll just notice the connections between them, and again, I would have put these in a little bit different order to make more sense, but if you look at the formulas, you'll notice that if you look at arc sine and arc cosine, notice that they're almost identical. The only difference is the co-function is negative. And if you look at arc cosecant with arc secant, notice again, same formula, only the co-function is negative. And same thing with arc tangent and arc cotangent, the co-function has a negative. So really the only three that you actually have to memorize are arc sine, arc secant, and arc tangent, and then the other ones are the co-functions just have a negative. So if it were me, and this is why I keep telling you it's not as many formulas as you think, you need to know these three, and then you just need to know if I do arc cotangent instead of arc tangent, all I do is stick a negative sign. Okay? So those are the three most important ones as far as memorizing formulas. We really won't see arc secants. I mean, it'll come up occasionally. It's good practice for some things, but really arc sine and arc tangent, and then just don't forget arc cotangent or cosine is just negative of arc sine. Okay, So when we're doing derivatives here, really we're just using a formula. Okay, so the formula for sine inverse, so this says find the derivative of sine inverse of 5x. So the formula for arc sine is u prime, that means the derivative of the inside, over square root of 1 minus that inside squared. That's it. So all I'm going to do is say dy dx equals, so the formula is derivative of the inside, that's 5, over square root of 1 minus the inside whole thing squared. And then I'm done. That's how easy it is. Finished. Don't need to do anything else. Tangent inverse formula is, now it's always derivative of the inside. We always have to do that because the inside is not this variable right here. So if it's not plain x, I have to do that. The general format for tangent is 1 plus whatever's inside squared. Then the top is the derivative of the inside, so that would be 1/2 2x plus 1 to the negative 1/2 times the derivative of the inside of that, which is times 2. So now let's just rewrite it, and we can even just leave the top 2x plus 1 to the negative 1/2. The bottom is 1 plus 2x plus 1. So we can go one more step, and if we want to, we could move the top thing to the bottom, or you can just leave it, because don't forget, not that big of a deal to figure out it goes in the bottom. And the bottom is 2x plus 2. Okay, so there's my derivative. So I do want to not leave, a square root squared. I want to go ahead and do it. And do your 1/2 times 2, add some like terms, and then that's about it. You should be able to match that to any number of things. Okay, so arc cosine, what I'm going to think when I do arc cosine is the same formula that I have for sine, for arc sine, except negative. So first thing I do is say, oh, it's arc cosine, so I'm going to put negative. And then it's square root of 1 minus the inside squared. And then, of course, we have to multiply times the derivative of the inside. And then you can stop there. Or you can multiply the bottom underneath and write 1 minus x to the 4th. But we can't simplify anything else, so don't think that you can. Like, you can't square root anything. So the only other thing really reasonable is to write 1 minus x to the 4th underneath the radical. But do not think that you can square root the x to the 4th separately. This is subtraction, so we can't do anything else with that unless you had a perfect square underneath. All right, so again, here's another one. Here's find the derivative of sine inverse. Again, formula. Formula is, the bottom is square root of 1 minus whatever's inside squared, that's in the bottom, and the top is just the derivative of the inside. So most that I would maybe do here is I might multiply out the inside, and here's where there might be a little difficulty matching, because we look at it and it's like, that's not going to really match my answers that I have. Now on your paper, you should have some room to do some scratch work to the right. I don't on here because this is not lined up quite the same as your paper. So let me actually make some space at the bottom, and this should be your area that you're doing to the right of where you just wrote that derivative. You should never be writing right in the middle of a paper. You have to always be on the left, okay? Always stay to the left. But you have kind of a square and I don't. So here's what we're going to do is we're going to figure out a little bit of that underneath stuff. So underneath we had 1 minus parentheses x squared minus 1 squared. This is what's under the radical. So I'm going to do some simplifying with that so that I can see what I can do for that and how that ends up under the radical. So this is going to be 1 minus parentheses. Now FOIL this, so that, or distribute, so that's x to the 4th minus 2x squared plus 1. Don't forget there's a middle term there. If I simplify this, I'm going to get negative x to the 4th plus 2x squared, and then 1 minus 1 will go away. So that's actually what's underneath the radical. So now let's write the radical with that underneath. I'm going to switch it and just make it have the x to the fourth second so that it's subtraction. I will notice that here I can factor out underneath. I can actually take out an x squared from those terms. And here's why that could matter. I have left a 2 minus x squared. But the reason it matters is this is multiplication. So now you can do each part separately. Nothing on the right is going to get simpler, but the square root of x squared is, and this is where you have to be really careful to remember, the square root of x squared is not x. It's absolute value of x. Okay? So this is actually how the entire denominator simplifies. Now, why would I do that? Only if I'm trying to match. So I get this answer because that's the way things go. And then I'm like, okay, doesn't match anything. So I'm going to have to go to the side and do some things. So your answer might be that you have to match it to this. Okay? And that's how it matches. Now, if you have a lot of trouble simplifying, rewind that and watch that again. And then pause it and really think about it. Okay? All right, let's go to some more examples. So, and we'll probably just do E, and then we'll go ahead and move to some tangent lines. So here again, format of the derivative of tangent inverse is that in the bottom you have 1 plus whatever's in the parentheses squared, and then the top is the derivative of the inside, so the derivative of cosine, which would be the opposite of sine x. And really, there's not anything else you can really write, except this is, you know, the only cleaner thing possibly is just to write the squared the way we normally write it. Okay, but that's not really gonna, there's nothing that's gonna simplify there, so that's the answer. Okay, so let's skip F. Let's go to this, this equation. So we're going to do the equation of the tangent line for this function. That hasn't changed. All I've done is add a formula. So the first thing your mind should think is, I need to do this derivative. Remember that arctangent is the same as tangent inverse. So again, our formula for tangent inverse is in the bottom, it's 1 plus the inside squared. And the numerator is the derivative of the inside, which is going to be 1/2. Okay, so that's my format for my problem. Now, I'm going to plug in a value. So I'm not going to mess with it too much. I could simplify it a whole bunch, but I'm going to plug a point in. So I'm just going to write dy dx evaluated at 2 comma pi over 4 is going to equal 1/2. Now, if you wanted to, one simple thing is put 1/2 in the front and make that a 1. I mean, that does make it a little less cumbersome. But then it's 1 plus, I need to plug in the x value, which is 2. That's 2 over 2, which is 1 squared. So now we kind of see why it would have been a lot of extra work to simplify it. Didn't need it. Might have needed it, didn't. So this is going to be 1/2 times 1/2, which is going to be 1/4. So what I found was my slope. So the tangent line is the same process. So to find the tangent line, it's y minus the y value, which was pi over 4, equals the slope times x minus 2, because they gave me the point, and that's it. So the only thing we've added is that you have the only difference is that you have to do a new formula. That's it. Otherwise, everything's the same. So when you're doing your homework, of course, your biggest problem here, or your biggest goal here, is to learn the formulas. Okay? All right, so we're going to do this next example. So we're going to have some implicit to do here. Or possibly some rewriting, actually. If we tried to do this implicitly, we would actually have quite a mess. So we're going to see if we can solve this for y and then do our derivative. And it will end up simplifying quite a bit. Actually, I'm not going to do that problem. I'm going to skip that one. Let's do this one as a little bit of a reminder about the derivative of the inverse of a function. Okay, so first thing that I do, it says let g be the inverse of the function. So when they tell me I'm finding g prime of 1, they're saying I'm finding the derivative of the inverse of f of x. So remember that our first step is that f of x is 2 cosine x. This number 1 is the y value for this function because they're inverses and we're switching x and y. So that means I want to solve when does 1 equal 2 cosine x. So this is when cosine x is 1/2. And so my values would be a bunch of values, but pi over 3 is the only one that fits in 0 to pi. Okay, that's the only time that cosine equals positive 1/2. So I only have one answer. So that means that if I do, it's telling me that f of pi over 3 equals 1. So in other words, on f, I have a point called pi over 3, 1, and on g, the function is called 1 pi over 3, or the point, sorry, is called 1 pi over 3. So the next thing that I do is I need to find the derivative of f, because the formula is 1 over the derivative of f at the other half of the point. So instead of at 1, at pi over 3. So first let's find the derivative. So the derivative of 2 cosine x would be negative 2 sine x. So f prime at pi over 3 would be to plug in pi over 3. So I would get negative 2 sine of pi over 3. Sine of pi over 3 is square root of 3 over 2. So those will go away. I get negative square root of 3. So last thing when I'm doing inverses, this is from the last section, is I know that g prime of 1 means 1 over f prime at pi over 3. So again, they're asking me to do g prime at 1. That means 1 is the y value for f, and I need to find 1 over the derivative at the x value, the other piece of the point. And since I just found that, this is negative 1 over the square root of 3, and I'm finished. So that's a little review that kind of throws that in there too of how to do that derivative of the inverse function. Okay, so that's all we're going to do for the video, and then we'll do some additional, we may do a couple of additional examples in class.